Look up on a clear dark night, far away from city lights, and you might spot a faint, fuzzy smudge of light in the constellation Andromeda. To the naked eye, it looks like a tiny, quiet cloud. But that smudge is not a cloud at all. It is the Andromeda Galaxy, a swirling, cosmic city of more than 1 trillion stars, located 2.5 million light-years from Earth. For centuries, we have stared at it as a fixed, peaceful part of the night sky. But today, we are going to tell you a story that will change how you see our place in the universe forever. This gentle-looking neighbor is on the move. It is racing toward us, and one day, far in the future, the Andromeda Galaxy and our home, the Milky Way, will meet in a collision that will reshape two galaxies into one. Let us start with the most basic fact. Almost everything in the universe is in motion. Planets orbit stars, stars orbit the centers of galaxies. Galaxies themselves drift, pull, and dance under the unbreakable rule of gravity. For a long time, astronomers focused on one big truth about the universe: it is expanding. Space itself is stretching, pushing most galaxies away from each other at incredible speeds. This expansion led to a logical thought: if the universe is blowing up like a balloon, all galaxies should be moving apart, never to meet. But the Andromeda Galaxy breaks that rule in the most dramatic way possible. Instead of moving away, it is moving toward us. And it is moving fast, about 250,000 miles per hour, or roughly 110 kilometers per second. That is fast enough to cross the entire distance from Earth to the Moon in just over 1 hour. How do we know this? The answer comes from one of the most powerful tools humanity has ever built: the NASA Hubble Space Telescope. For more than a century, astronomers noticed something strange about the light from Andromeda. Using a principle called the Doppler effect, scientists can tell if an object in space is moving toward us or away from us by the color of its light. When an object moves away, its light stretches toward the red end of the spectrum. This is called redshift. When an object moves toward us, its light squeezes toward the blue end. This is called blue shift. Andromeda's light is blue shifted. That single observation told astronomers one unshakable truth: Andromeda is not retreating. It is approaching, but knowing it is coming was not enough. For decades, we could not answer the biggest question: would it hit us or would it miss? The problem was measuring its sideways motion, also called proper motion. Imagine watching a bird fly far in the sky. You can tell if it is coming toward you or flying away, but it is much harder to tell if it is drifting left or right. For galaxies, this sideways movement is tiny and nearly impossible to measure. In 2012, everything changed. Astronomers used Hubble to take ultra-precise measurements of stars in Andromeda's outer halo, comparing their positions over several years against the fixed background of distant galaxies. The results were stunning. The sideways motion of Andromeda is so small that it is effectively zero for the purpose of a collision. The old doubt was gone. According to NASA's classic models, our two galaxies are on a direct course. Now, you might be asking, if the universe is expanding, why are these two galaxies moving toward each other? The answer is gravity. The expansion of space dominates on huge scales, billions of light years. But on smaller scales, like within our local group of galaxies, gravity is stronger. The local group is a family of about 50 galaxies, held together by their combined gravity. The Milky Way and Andromeda are the two giants of this family, each holding hundreds of billions of stars and massive halos of dark matter. Their mutual gravitational pull is so strong that it completely overpowers the stretching of space between them. The push of cosmic expansion is no match for the pull of 2 trillion solar masses locked in a cosmic embrace. This is not some rare accident. Galaxy collisions and mergers are among the most common and important events in the history of the universe. Most large galaxies, including our own, grew to their size by eating smaller galaxies over billions of years. Andromeda itself has collided with and absorbed other galaxies in its past. The coming collision is just the next chapter in this ancient universal story. Let's walk through the timeline of this cosmic event based on NASA's long-standing simulations and updated observations. Right now, the first phase of this encounter has already quietly begun. The invisible dark matter halos that surround both galaxies are already touching and mixing. We cannot see dark matter, but we can detect its gravitational effects. This halo merger is the opening act of the collision, a slow gravitational dance that has started long before the bright, visible parts of the galaxies meet. In about 2 billion years, the change will become visible to anyone still watching the night sky. the Andromeda Galaxy will appear much larger and brighter, no longer a faint smudge, but a prominent, glowing structure dominating the night. By 3.75 billion years from now, Andromeda will fill our sky. The gravitational tidal forces between the two galaxies will start to warp and stretch the spiral arms of both the Milky Way and Andromeda. Our galaxy's flat, beautiful disk will begin to bend and twist under the immense pull of our neighbor. This is not a violent crash, not yet. It is a slow, graceful distortion guided by gravity. Around 4 to 4.5 billion years from now, the first close encounter happens. The two galactic disks will pass through each other in a near head-on collision. But here is the most surprising part of the entire story. Stars and planets will almost never crash into each other. Galaxies look dense and packed with stars, but they are mostly empty space. The distance between stars is so vast that even when two galaxies merge, the chance of a direct collision between two stars is nearly zero. Our Sun and our solar system will almost certainly survive this passage completely unharmed. What will change is our place in the galaxy. Tidal forces may fling our Sun into a new orbit, much farther from the center of the combined system than we are now. After the first pass, the galaxies will not bounce away. Gravity will pull them back toward each other again and again. Each pass will warp their shapes more, strip away gas and dust, and trigger massive waves of new star formation, called a starburst event. Clouds of gas will slam into each other, collapse, and ignite millions of new stars in a brilliant cosmic fireworks show. Over hundreds of millions of years, the two spiral galaxies will lose their distinct shapes. The delicate spiral arms we love will be torn apart. By about 6 to 7 billion years from now, the two galaxies will finish merging into a single, massive new galaxy. Astronomers have already given this future galaxy a name, Milkomeda, or sometimes Milkdromeda. Unlike the spiral shape of the Milky Way and Andromeda, Milkomeda will be a huge, smooth, elliptical galaxy. It will be a giant, rounded swarm of stars with no defined disk or spiral arms. The bright, busy core of this new galaxy will dominate the night sky, if any skywatchers are still around to see it. We also cannot ignore the supermassive black holes at the centers of both galaxies. The Milky Way has Sagittarius A multiplied by a black hole, about 4 million times the mass of the Sunday. Andromeda's central black hole is much larger, roughly 100 million times the mass of the Sunday. As the galaxies merge, these two black holes will spiral toward each other, drawn by gravity. Eventually, they will merge into one even more massive black hole, sending ripples through space-time, called gravitational waves, that will spread across the universe. In recent years, new research has added a layer of uncertainty to this classic story. Using data from the Gaia satellite and updated computer simulations, some studies now suggest that the collision may not be as certain as once thought. One 2025 study published in Nature Astronomy ran 100,000 simulations and found that the chance of a collision within 5 billion years is less than 2%. Over 10 billion years, the probability rises to about 50 to 50. This does not mean the collision is cancelled. It means our measurements of the tiny sideways motions are still improving, and the universe is full of surprises. Even if the timing changes, the long-term fate of our two galaxies remains linked by gravity. Now let us talk about what this means for Earth and for life. The honest truth is that this collision will not threaten life as we know it, because life on Earth will likely be long gone before the first close pass. Our Sun is about 4.6 billion years old. In about 5 billion years, it will run out of hydrogen fuel, expand into a red giant, and swallow the inner planets, including Mercury, Venus, and possibly Earth. The era of life on our planet will have ended long before the galaxies finish merging. The collision is not a disaster for us. It is a distant, beautiful event that belongs to the far future of the cosmos, not to human history. This story teaches us something profound about our place in the universe. We often think of our galaxy as a permanent, unchanging home. But the universe is dynamic. It is alive with motion, change, and transformation. Galaxies are born, grow, collide, merge, and evolve, just like stars, planets, and living things. The merger between Andromeda and the Milky Way is not a destruction. It is a rebirth. Two old spiral galaxies will become one new, giant elliptical galaxy, carrying the stars of both lineages into the next era of cosmic history. Think about the stars that will exist in Milkomeda. Some will be stars that were born in the Milky Way. Some will be stars that were born in Andromeda. Planets orbiting those stars will have skies that hold the combined light of two once separate galactic families. On some distant world, if life ever arises there, creatures might look up and tell stories about the ancient collision that built their home. They will never know the separate galaxies that came before. They will only know the unified giant galaxy that resulted from that ancient cosmic dance. As we wrap up, let us return to that faint smudge of light we see in the night sky. The Andromeda Galaxy is more than just a deep space object. It is a cosmic partner, a neighbor, and a future family member. It is proof that the universe is not a cold, static place. It is a story still being written with gravity as its pen and galaxies as its characters. We are lucky to live in a time when we can use telescopes like Hubble and Gaia to read that story, to understand our past, and to glimpse our distant future. The answer to our question is clear: yes, the Andromeda Galaxy will collide and merge with the Milky Way in a future billions of years from now. It is not a question of if, but of exactly when. And when it happens, it will be one of the most magnificent events our corner of the universe has ever seen. Please like, comment, share, and subscribe to the channel.